Okay, let's have a class. And several announcements. First of all, I want to say, we will do lab final exam December 1st. Okay, so we'll do on Thursday instead of the Tuesday, because on Tuesday, lots of your mind is still among the turkeys and not come back yet. So we'll let you have 3 days to adjust yourself back to normal, and also the time you can find your bench partner, your friend to study. And our TA, Carly Long, will have a review section on Monday and also on Tuesday. So you can join if you need it. Okay, and I already did a review and the videotaping for the lab section in the morning. We start from 10 o'clock in the morning because the weather is a little bit bad. So I delayed the 30 minutes to start. So this is the first one. Second, today we will talk about the poultry processing. And finish these slides, we talk about poultry processing. Back from the November 29th, this day we don't have a lab. The lecture will continue. We're going to talk about immunology. And December 1st, there is no lecture. December 6th, we hopefully to finish the virus and also finish the review. Because last section, there's not much material. So here is the deal. December 8th, right here, 11 o'clock. If you want to do early exam, you can come in to do. That's the first spot. December 8th, 11 o'clock, the normal schedule of the lecture time. The second early exam is December 9th, 12 to 3 o'clock in the lab room Friday afternoon, if you want to do. Then there will be the normal scheduled university time. I believe, did you check? I believe it's December 15th, is that right? December 15th, early in the morning, that is 8 o'clock, not 11 o'clock. I have people who told me they oversleep and they forgot. It's not 11, it's 8 o'clock in the morning. So I offer you 2 early exams, December 8th and December 9th, and December 15th, 8 o'clock early in the morning is the normal schedule time. I want to do that is because some of you really do very well, and you can just normal study, you can get an A, that's good. But don't study the 25 points or 30 points if you only need 30 points. I don't want the exam paper is all empty. Okay, only that couple of spots is filled. You still do it normally, but you're feeling it's comfortable. You do earlier, you can do it earlier. If you need extra time to study, then I will say majority of you, December 15th will be a good time. Another thing is that, because you know, December 18th is the last day. We must update everything into the grade system in the university. It's very tight schedule if everybody do December 15th. So that's why I offer those 2 early spots, and we can finish those, we can upload into them first. Okay? I don't know whether you can see it, but we can upload those first. I also got to put on the eCampus tonight, or maybe tomorrow. It will be the extra points for the small essay writing, the topics. There will be 30 points for the lecture. Okay? Now lab, the extra points is the lab notebook. 20 points. So we will talk about that in the lab section. So these are a couple of the announcements before we start. Okay, we want to finish these slides, but before that, we will do a little bit of briefly review. In the final exam, they're going to have something which is you need to write. Okay, so we're going to ask you, for example, what is HACCP? This is what we talked about. Hazard analysis, critical control points. Okay, this is in 1996 Federal Register. Required. It's called the pathogen reduction and the HACCP. And we mentioned about it a little bit ironically, this pathogen reduction not really is E. coli 157H7. It's Salmonella, and file type 1 E. coli. It's a surrogate, actually. Okay, so what are the 7 principles of HACCP? Conduct hazard analysis. Establish critical control points. Number 3, establish critical limits. And this critical limit is a physical, chemical parameter corresponding to critical limits. Conduct monitoring procedures. Number 5, conduct corrective actions. If there is a deviation happens. Number 6, verification, validation procedure. Last one, record keeping and documentation. So that is the 7 principles of HACCP, okay? Very important, you should know. It's another class. If we talk about HACCP, that's going to be a single class. But this is a key thing you should know. Before we talk about, we just do a brief review. Okay, this slide is important. This is talk about in the United States, the food safety related agency. So what are they? Number 1 is CDC. You heard about the whole year. For all the time, Centers for Disease Control and Prevention. That's why the vaccine regulations all come from there. It's for prevention. From the food safety standpoint, they have a puzzle net. Or we call it a food net. What are they? They are using PFGE, puzzle field geoelectrophoresis. This is a molecular microbiology mapping. Microbial mapping system. What this means, they have a database of all E. coli 157H7, Listeria monocytogenes, Salmonella, different strains. There's a round puzzle field geoelectrophoresis, which is called PFGE. You only need to know the acronym is PFGE. So they have it. They compare the pathogen involved in the outbreaks. Are they map? Are they really matching their PFG database? They're using called 3-band rules. As long as you have no more than 3-band difference compared to the PFG pattern of their database, then we will say 99.9% the pathogen involved in the outbreaks is match their database. Then they can tell people what you should do to do the prevention. And hopefully, okay, to be honest, is hopefully. So that's what the rule for CDC as food safety. So food safety, from the food safety standpoint, the CDC is for surveillance. But the regulation is really the other two. Number 1, USDA, FSIS. What is USDA? You know that. Department of Agriculture. So who is the secretary? Tom Vilsack, okay? We don't know, we're not going to test you, I just let you know. What is the FSIS? Food Safety Inspection Service. What they are responsible for is meat and poultry products and processed egg. Regarding egg is tricky. If the egg right between a sandwich, you buy a breakfast in Starbucks. You said, I want what we call it? Big Mac, or they are from McDonald's, sorry. You had a egg right in the middle. This is processed egg. That's belonging to the regulation of FSIS. How about raw egg? That is for FDA. Okay, what is FDA? Food and Drug Administration. Now, what else they are responsible? I would say any products other than meat and poultry products and the processed egg. So basically it's others. Now what are they? Fresh produce. That means fruits and vegetables. Juice, all the others, okay? So this is a regulation you need to know. Processed egg, can you see it? Domestic imported food, all the others. So said very simple is all the others. Please know the acronym of these three agencies. Why? There is lots of the opportunity of the internship and the future government jobs. They are in there. You may go ahead and find a job after a couple of years when you graduate, or you get a master or PhD degree. So that's why those names is very important. And I have a student that called me one day in the parking lot. He said, Dr. Shen, I find a job in the FSIS. And I know this in your class. Then I apply for the internship, in the summer internship. So that's why you need to know all these three agencies. These are major responsible for the food safety in the United States. Okay, so for example, HACCP comes up from FSIS. The Food Safety Modernization Act, which is FSMA, coming from FDA. Now, politically, there is generally speaking, FDA is trying to take care of everything. That's why they come out with the FSMA. The preventive control methods, very similar to the HACCP. So there's a debate about that. They may be borrow a lot of stuff from the HACCP, from the FSIS, go to the FDA. Okay, just something else, I just want to let you know. But these three agencies are important for the food safety management, surveillance, regulation in the United States. Okay, so we finished this part. This is for the next one. We're going to talk about the poultry safety. Unfortunately, the slides is too large. I cannot upload, so I can only do PDF. Okay, so let's talk about pathogen control of the poultry processing. We're going to have to remove all these. So we're going to talk about the detail of that poultry processing. You may learn a little bit if you are pre-vet students in Davis College. Dr. Joe Motz have the similar class about the poultry processing, and he may mention about that. But we are going to talk about the detail here. We'll pay much attention to microbial safety standpoints to let you know the poultry meat safety. First of all, based on the survey in the United States, 2014, the broiler production in the United States, you can see what are the major poultry states. is in the south. You know about that. Georgia, Alabama, Mississippi, Texas, North Carolina, basically is in this south area. And Pennsylvania has a lot, Virginia has a lot. Kentucky used to be dominant, but they are trying to get rid of the poultry waste, because the fecal waste is very difficult to control. And very interesting, did you see West Virginia is right there? 95.3 million head in the state. We don't have a big agriculture industry. You know, history, we are mining and a little bit of stealing, basically is mining. However, from the agriculture industry, we had a big poultry generators. And most of them are in the Eastern Panhandle, which is Hardy County, is one of the big counties have the poultry generators. And most of them are backyard poultry generators. It's very amazing. You see how many local processed poultry contribute to the great amount of the agriculture production in the West Virginia every year. And nearby Ohio is okay, a lot, but all the others, not too many, especially in this area. This area basically is beef and cattle. Colorado, Kansas, Wyoming, it's a cattle state. Okay? Other things you need to know. There is a 6 university in the United States have a poultry science department. University of Georgia, University of Auburn University in Arizona, Mississippi State University, University of Arkansas, Texas, AEM University, and North Carolina State University. They have a very good poultry science department. So if you are interested, those are the places good for you to do a PhD or a master's study further on. Just to let you know. Just let you know, because the poultry is a big products in their area. Okay, so just let you know, this picture tells you West Virginia poultry is important and the total broiler production in the United States. Okay, for the poultry processing, what do we care about the foodborne pathogen? We already mentioned, lots of them are all important. Recently, if you look at the literature review, Listeria monocytogenes is a big one. E. coli O157H7 could be. Norovirus could be. Clostridium botulism, lots of people talk about it. It's an endospore bacteria. But traditionally, we still care about 2 major pathogens. Is Campylobacter and the Salmonella. So we want to talk a little bit about that. Campylobacter. This is a gram-negative large shape. And the gross temperature, 42.5 degrees Celsius. Very interesting, because that is exactly the intestinal temperature of birds, of a chicken, of a broiler. And the turkey, the same thing. A very tricky thing for Campylobacter. This is a aerophilic bacteria. So, they only survive around 2 to 5% of oxygen. If more oxygen there, they will be died. It is a very tricky stuff. Campylobacter is very difficult to grow in the lab situation. However, it is a big risk for poultry. That's very ironically, and nobody knows why. The poultry industry thinks it's a big deal. FSIS is a big deal. However, if we wanted to do a validation study to grow in the lab, it's very difficult to grow. Lots of the time, it's not going to grow. It's a typical fastidious bacteria. You need a gas diaper, we call it a gas diaper, gas generator. We need a jar, a specific jar, and the environment has to be exactly 2 to 5% oxygen. If you have more oxygen, it will be died. However, we find that this bacteria can survive very well on the poultry surfaces, on the skin surfaces. Maybe the niche area of the skin surfaces create a microaerophilic environments. That's one of the hypotheses about that. But it's very interesting, this bacteria. We did a lot of in my lab. We did a lot, but it's difficult to grow. So, for example, you can grow E. coli just in your TSB, tropic soil agar, nutrient broth. It won't grow. You need to use a very special media. It's called a bottom broth media, specific for Campylobacter. But it's expensive. One bottle is about $500, only 200 liters. So that's a tricky thing. We need to add vitamins, add other blood cells sometimes, a lot of the ingredients there to make it grow. So, and they have a method called FDA, CAP agar, which the ingredients is already there. Okay, so that's a Campylobacter. Campylobacter could be survive in the intestine of a wide variety of the domestic and wild animals. It's about 2 to 4 weeks to survive, and the best temperature can be as low as 40 degrees Fahrenheit. That's very low. That is almost only 4 to 5 degrees Celsius, which means it could be survive in the refrigerator temperature. Room temperature 2 to 5 months. It is a big risk. However, I tell you, the infectious dose is very high. It needs to be at least 500 cells. Remember, E. coli 0157H7 is zero tolerance. And how many cells will cause problem? 10 cells will cause HUS, hemorrhagic uremic syndrome. But Campylobacter, 500 cells just reach the risk dose range. Okay, that's Campylobacter. Salmonella, we already know. We don't need to mention this too much. Salmonella is a gram-negative, large-shaped bacteria. It's a facultative, which means they grow in the presence, absence of oxygen, grow better with oxygen. So nothing special, very similar to E. coli. And I tell you one thing, their optimal temperature can grow 35 to 44.5 degrees Celsius, can go up to. This is a tricky thing. I want to mention to you. This is a very tricky thing. Grow well at the body temperature. The maximum is 45 to 47, can be grow as low as 5 degrees Celsius. A very wide range of the pH, can pH 4 and pH 9. Optimal pH 6.5, 7.5. What means pH 4? Little bit acid resistant. What means pH 9.0? Little bit alkaline environments. So that's for Salmonella. Okay, this is 2005, the survey. Is the top 30 serotypes. So number 1, typhimurine. Then epidermis. Epidermis basically is in the egg. Then Newport. Then Salmonella Hindenburg. These are the top 4 in the poultry meats. You can add up them together. Almost 50% of the outbreaks, isolates coming from typhimurine, epidermis, Newport, and Hindenburg. I need to mention one thing again. You probably you forget. Salmonella, genus name, italic. Lots of the time, if we write Newport, it's just normal. Why? Because it's a 6 subspecies. When we talk about the Salmonella typhimurine, Salmonella epidermis, Newport, it is actually Salmonella enterica, subspecies enterica, Newport. This is italic. However, lots of the people think this name is too long, so they cut these out. Then become Salmonella italic, Newport, just normal. Okay, just want to let you know a little bit different. When you see E. coli, it's Escherichia coli. Escherichia and coli, both of them are italic. This is not. Okay, that's why. It's because the Newport, it is a subspecies name. Okay, that's Salmonella. Okay, this is a big deal. Okay, E. coli 0157H7, we already mentioned. Zero tolerance. Okay, how about Listeria monocytogenes? I forgot to mention. Listeria monocytogenes in risk products, let's say ready-to-eat meat and hot dog, it's still zero tolerance. But Listeria monocytogenes basically can be allowed to have 100 CFU per gram, up to, in a low-risk food. Salmonella Campylobacter, much higher. So, Broncococcis, keep in mind, is not Salmonella and Campylobacter free. This is 2015, a relatively new performance standards on the poultry broiler coccyx, which is the one we did in the lab, the whole coccyx. Food Safety Inspection Service is allowed they have up to 7.5% positive for Salmonella and 10.4% positive for Campylobacter. So keep in mind, poultry meat, you can eat raw, and you can cook to medium well done. Of course, nobody order like that because of the quality. Is that right? Because of the color. We talk about tenderness, flavor, and juiciness. Keep in mind, it has to be well done. The internal temperature, 74 degrees Celsius. You have to be careful about that. Because if they are allowed to have Salmonella up to 7.5, Campylobacter 10.4, not zero tolerance. Just most recently, just to let you know, the breaded, stuffed, frozen chicken nuggets, those type of the products, the FSIS just have a new regulation. This type of products is Salmonella zero tolerance. Why? Who is the person who eats those products? Kids. Is the right 5-year-old, 3-year-old kid eating chicken nuggets every day from chicken fillet? These are the risks. And those are called not ready to eat meat products. However, they deep fry a little bit. So looks like it's well cooked, but not. It's tricky. So those breaded stuffed frozen chicken nuggets and other chicken products is the same. Maybe chicken wings or other things is the same thing. That Salmonella is zero tolerance right now. It's just brand new for the FSIS regulation. But lots of people are mad. I just want to tell you. Once you have a zero tolerance, those processors is really freaking out about it because they have to control, well controlled. Okay, this is a broiler processing. A standard broiler processing. Okay, you're gonna live hanger there, immobilization, bleeding. We call it exquisition. Take out the bleed. Then the scottering. Put in the hot temperature. Take out of the feather. We call it defeathering. Then pickling. Evisceration. Then we do the chilling. We do the aging. That is basically the vacuum package. We have a dry age and a wet aging, two different type of the thing to make the meat is more tender. Then further process products and the packaging, and then do the transportation. So we want to talk about several things related to the microbial safety among these processing. First of all, scottering. Scottering is a very old method. First century AD start to use. In the Egypt country, they start to use. In the African countries. This is scottering. Use hot water going through the conveyor belts and then try to do the defeathering. Okay, here is a tricky thing we want to mention. This is scottering temperature. The temperature control is the key. There is two different types of the scalding. Is hot scalding, 59, 64 degrees Celsius, 30, 75 seconds. Soft scalding, 51, 54 degrees Celsius, 90 to 120 seconds. Be careful. There is two mistakes is easily to make. Number one, lots of the small processors, because they want to easy to handle it, so they think it's too hot, especially small producer. They using temperature around 45 degrees Celsius. Because it's easy to handle, it's too hot. What is going to happen? Your cultivation bacteria. Look at salmonella, 35 to 44.5 degrees Celsius, can go up to 47. So, you can do temperature as low as 45 degrees Celsius because you are actually culturing bacteria. You are growing bacteria. If the scalding processing, you go there took a longer time, the chamber, go like a whole day or half a day, then you're culturing bacteria if you use 45 degrees Celsius. Okay, second mistake. Okay, it's hot, is that right? So people were thinking, let's go up a little bit high, at the same time can killing bacteria. So what they do? They go up 65 degrees Celsius. What happened? You're cooking the birds. Then what happened? Fatty acids, basically fat, will accumulate, will be extracted out of skin and accumulated in chilling tank later. And I tell you, this will be a big tricky there. So, not high temperature. You can do like that. Definitely below 64 degrees Celsius. And if you have temperature, it's short time. Last one, very important. The water flow counter current. What this means? Birds always facing fresh water. Water go this way. Birds go the other side. That's called a counter current. Very difficult to do, I tell you. Lots of the small producers, they don't do it. When I was in Kentucky, I go to see the several plants, they don't do it. It's hard to do. Counter current water flow is a little bit difficult to do. Lots of new energy. So always remember the best thing to do water flow is counter current. So this is the first tricky thing for the scalding temperature. The temperature control is very important. Are we going to add antimicrobials there? No, very few we added because it's too hot, the temperature. And also, organic matters is cover the surfaces, so we don't use it really. Very few antimicrobials we use, so this is scalding. Pickles. What's the key for this one? Feed withdraw. Okay? Picking. Withdraw food. Withdraw feeds around 18-24 hours. No longer than that. You cannot do too short. What happens if too short? The alien and the CK area, intestinal area will be filled with all the feeds. And we did a bacterial analysis of the chicken feeds. Horrible, it's lots of bacteria. So, you can't do like just feeding the feeds today and tomorrow morning you're going to kill them. No. Also, you cannot do too long. You can withdraw feeds for 48 hours, 72 hours. What happened? The CK will be very soft by the time. Intestinal is very soft. When you broke down, it goes everywhere. That is a major contamination is from the CK is the intestinal area. Okay, that's a pickles. This is the next step. We call it evisceration. Evisceration, which means you take out of the intestinal area, out of the body, left the chicken carcass is just empty. This is a major point for cross-contamination. If the equipment is not adjusted correctly, improper feed withdrawal and weak intestinals, that withdrawal of the feeds is important because this is a major processing will cause cross-contamination. So what we do? Most of the time, after evisceration, we go back here. After evisceration, lots of people just continue to do the chilling. But the big companies, the large company like Tyson, Smithfield, Purdue Farms, they add one more step between here, around here. It's called inside-outside bird's wash. This is what it looks like. What this means? Inside, outside, bird's wash. This is usually do before chilling. And we put them back to the processing line. We call it online reprocessing procedure. Okay. Obviously, we need to use antimicrobials. And we need to use a nozzle to do the spray. Nozzle to do the spray, sorry. About like 30 seconds, not too long. Some people even do 50 seconds. I want to tell you how many bacteria can really reduce that. 1 to 3 log 10 CFU per ml. Averagely 2 log 10 CFU per ml. It's not going to curing everything. I just want to tell you. But people do it and very effective. This is inside-outside bird's wash. Okay, what are the antimicrobials using for the inside-outside bird's wash processing? By the way, OLR is online reprocessing process. Okay, online reprocessing. This one we also call it OLR. That's an acronym. So we use antimicrobials. This is lots of several things we could talk. Okay. What is the major antimicrobials using in the online reprocessing process? This is done by Dr. Shelley McKee in Auburn University back in 2013. They did a survey in the South area, in the southern part of the United States. The number one antimicrobials is always 40% using is peroxyacetic acids, is a PAA. So number one, peroxyacetic acid. Okay, what is that, peroxyacetic acid? This is acetic acid. That's acetic acids combined with hydrogen peroxide. They combine. I want to tell you one thing. There is another product generally. It's peroxyacetic acid. Adding more H2O2 become a product called samidate. This is in our local community, people using a lot. Why? Because it's organic certified. So that's first one. Number one is peroxyacetic acid. Number two is chlorine. Used to be chlorine is the number one, but why number two is chlorine? This is old, it's already changed. The number one country imported United States poultry is Russia and other European countries and EU, and they not allow you to have a chlorine during the processing. because chlorine will generate chloramine, halomethane, chlorine, halomethane, all those chlorine byproducts. So, number one in the United States using the South is PAA. But I don't think in the future we're going to have anything business with Russia anymore. So this is going to be changed a little bit. But this survey tells you it's old time. It's about 10 years ago. PAA is the number one, following by chlorine. So what is chlorine then? What is chlorine? Dissolve in the water, become what? This is free chlorine. There is two things important to generate the maximum amount of the free available chlorine. Number one is pH. This is why the industry people are using citric acid to adjust pH to 6.8. So, give you a very example. You buy a big chunk, a bucket of Clorox from Walmart. Okay, a Clorox from Walmart. And then you just dump it somewhere. Then you don't go to clean. It's a wrong way to do. Technically, because at that time, the pH is higher. The pH is about 9.5 to 10. Majority of the components is chlorine ions. So what they should do? You don't have citric acids, you can add a little bit lemon juice or vinegar there. Some people do that in the local community. Then adjust the pH a little bit below or close to the neutral. Then the dominant will be hypochloric acid. Okay, this is called hypochlorite acid. This is chlorine ions. So that's the first thing. The second thing, chlorine pH cannot be lower. Is pH lower than 4, what's going to happen? They go this way. Off gas. I was working in the Taylor Farms almost 12 years ago for my project. If you keep adding chlorine, what happened? Finally, you're tearing. You're not sad because you're tearing, because off gas comes out. The eyes cannot survive. So, if the lower pH will generate off gas. So the pH control is important. Number 3, organic matter. What it means? Soil and the dust has to be cleaned. This is very interesting. So easily to say, when you add a chlorine, you're doing sanitizing. Before you do sanitizing, you must do the cleaning, physical cleaning first. To remove these food soil, we call it organic matter. Because the research has been showing, if you prepare 50 parts per million chlorine, you are adding organic matter there. If it's in a juice solution, 30 seconds, this is go down to below 0.5 ppm. So when you prepare chlorine, the beakers, the container must be cleaned first, free of the soil. Those called organic matter. So that's why it is difficult to do. And I can guarantee you, when you wash the birds, you wash 100 birds. At the beginning, you prepare 100 ppm, parts per million chlorine. After you wash the birds, you will see it's maybe only 2 ppm there. It's go down dramatically. And the only thing you left is chlorine ions, and they could generate methane, trihalomethane, all those chlorine byproducts. Okay, so just to let you know, chlorine is very tricky. The third one is, we call it a strong or weak acid. This is what happened, is a strong weak acid. So acetic acid is one of them. This is, we're going to talk about a little bit chemistry, okay? So this is acetic acid. Acetic acid is a weak acid. So weak acid, basically, will be become two type of the bond, and protons come out. So you can do a value which is we call the pKa value, which is the pH at which the so-called the dissociated components, the concentration, and is the same as undissociated concentration. And that pH is called the pKa value. And basically we need to using, if it's acidic acids, the environment has to be lower than pKa. Because when you penetrate into a bacterial cell, only this guy will come in. This is not going to come in. Okay, when they come, what are they going to attack him? ATPase. They're going to attack ATPase. So bacteria, what are they going to do? They will hydrolyze bacteria, use ATP, become ADP and phosphates. So bacteria finally is exhausted. Because when they exhausted, they could repair the proton out of the cell membrane to keep the balance. So in the bacterial cell is only undissociated format will go into the cell. So this dissociated one will not come in. That means the pH has to be less than pKa. Lots of the times they are 4.5. So what this means, if you use weak acid, the only way it will be maximal its antimicrobial efficacy is in a lower acid environment. That causes another problem, is a corrosive of the person to do it. So that's why strong weak acid not many people are using. ASC is acidified sodium chloride. That is actually very low pH of the chlorine solution. CPC, if you remember central pyridine ceratite, if you remember, we mentioned about that.